Welcome back to part 2 of the video on quadratic polynomials and their graphs. Today we are going to be looking at the features that we can see from a graph when it's given to us in factored form. So a quick review of yesterday, the important features of a graph of polynomial. Probably the most important feature is the fact that it's got a highest or lowest point called the vertex. We're going to be finding that again today. It also has a y-intercept, which won't be useful for today's purposes, but is good to know. The thing that we want to highlight today is these roots, these zeros. And so if you're given an equation in factored form like this, then those roots and zeros are going to be easy to spot because it's just whatever it is that makes these things zero. And you have experience making those things zero and solving equations, right? So standard form, lots of different things that it gives us. Remember in that other video it told us the vertex and the y-intercept right away. In factored form, what we will be focusing on for sure is those roots and those zeros. And then you can use that to find the vertex, because the vertex is going to always have to be exactly halfway between them on the line of symmetry. And so anyway, let's take just a couple official notes on that. If you want to find the roots, they're simply the solutions to this equation. Basically set each chunk equal to 0 and solve it. And then you can find the line of symmetry by finding the average of those roots. And once you know what the line of symmetry is, finding the vertex is simply a matter of taking that x and plugging it in. So let's look at a couple examples. And says here, find the roots and the vertex and tell whether the graph opens up or down for the following. So this is given to us in standard form. And so when it's given to us in standard form, we can find it's not standard form, it's factored form. Said that wrong. Given to us in factored form, that means we can set each of these factors equal to 0. And when we do that, x plus 5 equals 0. If you subtract 5 from both sides, you get that x equals negative 5 is one of our roots. And when you set this factor equal to 0, adding 7 to both sides gives us that 7 is one of our roots. So now I know on that x and y plane that it intersects the x and y plane at a negative 5 and a positive 7. Problem is, I still don't know if it opens up or down. I don't know where the vertex is, but I do know that it's anchored in place at those two roots. To find the vertex, we need to continue by finding the line of symmetry. And the line of symmetry is going to be the average of these two roots. And so we're going to add them up and divide by 2. So negative 5 plus 7 divided by 2 is 1. And so now we know that the vertex is 1 something. So I have 2 points where it's anchored in. I know the vertex is 1 something, but I still don't know if it opens up or down and where specifically, how high or low that highest or lowest point is. And so to find the y-coordinate of the vertex, we take that 1 and we plug it in for x, and we calculate what y is. And so in this case, if we plug a 1 here, 1 plus 5 is 6. 1 minus 7 is negative 6. If we take those two, since this is a multiplication format, and multiply them together, we get that the y-coordinate is negative 36. And therefore, our complete vertex is 1, negative 36. So now that I've got all sorts of different information about this, I can make a pretty good graph of it. So let's do that a moment. So here's an xy plane. I know that its vertex is at 1, negative 36. And so if I take this and move this over a little bit, if I move this over a little bit and down quite a bit, it's going to eventually have its lowest point at 1, negative 36. And then I also know a couple of other points it goes through. It has to go through x of negative 5. I was afraid it was going to do that. So it's got to go through negative 5 and also through, all right, I'm not going to be able to draw this as to scale as I wanted to, but it's got to go through negative 5, so that'd be a point over here, and it has to go through 7 over here. And so anyway, that's a pretty good graph considering it wasn't really that much hard work to calculate those things. Let's look at another example moment. So in this particular example, the factors that we were given are a little bit messier than we had before, but our initial goal is going to be to find those roots. And so we can do the same sort of thing by setting each of them equal to 0. So if we do 2x plus 6 equal to 0, that's going to be a two-stepper to solve to get x alone. Probably subtract 6 from both sides and then divide both sides by 2. That gives us one root is -3. On this particular problem, probably again, 2 steps, subtracting 6 and dividing by -3 gives us that x equals 2 is our other root. And so now that we know where our two roots are, if we go to average them, we'll get the middle of our graph, our line of symmetry. And so adding those up, -3 plus 2 divided by 2, that's a -1/2. And so we know our vertex is going to be -1/2, but something. We're not sure how high or low it goes yet. So now the last step would be to take this -1/2 and plug it in for x in each of these cases. This gets a little ugly because working with fractions and some pretty complicated stuff is not the nicest. I used a calculator on it, and so if you put 2 times -1/2 plus 6, 3 times -1/2 plus 6, I'll type that into your calculator. I eventually got -1 plus 6, which is 5 times 7.5, for a final grand total of 37.5. And so that means our vertex is -1/2, -36. So with our roots and our vertex given to us, we can do a pretty good job of making a picture of this. So this time I know that the vertex is at -1/2, -36. Is it -36? No, it's not. That was from the last problem. 37.5. There we go. Let's see. I know this time that the vertex is way up high. So way up here and backwards -1.5. And I also know that it's got two roots. I know that this has to cross at -3 and at +2. And so what that means is that this has to be a graph that opens upside down. Let me see if I can make that happen. Yeah, there we go. So there, this is a pretty accurate curve of all that. All right, one last example, and then you can try some of these things on your own. In fact, if you want, you could pause it and try this problem on your own right now. One challenge, I guess, is that it was not given to us in factored form. So we either think about it like standard form, like the video from the other day, or we put it in factored form. And so I'm going to suggest putting it in factored form so we could take advantage of some of this thinking. To put it in factored form, I would need some parentheses, right? It's going to be x's to multiply to x, and I'm going to need a combination of numbers that multiply to 16 and add up to -10. There's 1 and 16, there's 2 and 8, there's 4 and 4, and then there's negatives of those. And I think it's the -2 times -8 combination that'll add up to -10. So there we go. If we factor it, it looks like this. If you want to hit pause, now's your chance to try to find everything, and then I'll show you. All right. Setting the first factor equal to 0 reveals that one of the roots is 8. Setting the other factor equal to 0 reveals the other root is at 2. So next thing would be to find the line of symmetry by averaging them. And so if we add them up and divide by 2, that's 10 divided by 2 is 5. Last step then would be to put a 5 into an x. Here you have a choice. You could put a 5 into this formula or to this formula. Both of those should give you the same value. I chose to put it into the factored form because, frankly, I think it's easier to work with. And that gives me a -3 times 3, or a -9 for a lowest point that this vertex goes. And so finally, if we wanted to make a graph of this, we know that its highest point, actually, I think it's going to be its lowest point. getting ahead of myself though. I think its lowest point is 5, -9. I also know that it has roots at 8 and 2. And so let's see if we can put this in about the right spot. So here's a root at 2, here's a root at 8. And in order to have a vertex at 5, -9, that must be a graph that opens up like this. So, anyhow, I hope that you are able to find roots and vertices and lines of symmetry for things in factored form. Let me know if you have any questions, and I'll catch you in the next video.